Alrighty, the last thing that we're going to talk about before we just kind of start reviewing for our test is the applications of factoring. And you've actually been seeing these throughout the unit. I just thought I'd compile one big topic that's strictly devoted to the different word problems and scenarios in which you will see factoring. I wanted to start, before we do that, with just an example using just a plain old whole number. So it says fill in the following and label the shape when necessary. So the area of this rectangle is 51. Okay, well, how else could I write that as an area? We'll come back to that. The side length, what times what will give me 51? We think about it, It's not prime even though we think it might be, and it's actually 17 and 3. Okay, so we know that 17 times 3 is 51. That's the other way to write the area, 17 times 3. Okay, so now side length 1, well, we could call that 17 if we wanted to. Side length 2 would be 3. Now the perimeter, how do I get the perimeter? It is not just 17 plus 3. I cannot stress that enough, okay? You have to add 17 and 3 as well as this 17 and 3 over here that we can't really see, okay? I don't know what happened to that note right there. So our perimeter would be 40. Again, that's 17 plus 3 plus 17 plus 3. So now, using that as kind of our barometer, let's look at the next problem. It's no different. This time I am telling you the area of this shape is 9x squared plus 12x. Oops, 9x squared. Over the multiplication, so plus 12x minus 32. Okay? Now, the way I break this down into something times something is a little bit more complicated than I did at the top, right? It's not just, oh, what is it, 17 times 3? No, we actually have to sit here and do our steps, right? So I went ahead and brought in the flow chart that you got in topic 4. The first step is always the same. I need to factor out any greatest common factors first, okay? Well, 9, 12, and 32. I know 9 is divisible only by 3 and 9, with 12 and 32 will not work. So, check, done that. Can it be grouped? Well, it's 3 terms, so no. Okay, I'm going to go this way. Is it a perfect square trinomial? Well, that's interesting because I know that 9 is a perfect square, right? 9x squared is a perfect square, but 32 is not, so no. Okay, which means it's obviously not a difference of 2 squares either. So my final last-ditch effort is to use the x factor. Okay, so big ol' x here. Remember that the top is a times c, so negative 32 times 9. It's a big number, 27,288. Okay, and the bottom would be b, which is 12. So now I think, oh, and this is negative. So now I think, what times what gives me 288 and adds to 12? Whew, which this might take me a while. The quickest shortcut I can give you is whenever you feel like you have a big number and you don't want to sit there and go through the factors, like 1 times 288, 2 times 144, 3 times 96. You can find the square root, and you can actually start with the bigger numbers, and that might be a little bit faster. So the square root of 288 is somewhere in between, let's see, 17 and 16. So let's start. I'm going to pull up a calculator. I think I can do that in here. Ooh, pause. Hold on. Okay, I couldn't find a calculator in this program, but I went and got one off my desk. So 288. I know that that is, I'm starting with 16. I'm doing 16 times 18. I'm dividing by, it's not 15. That won't work. Doesn't work with 14. Doesn't work with 13. 12 times 24. What do you know? So 12 and 24 would be our winner here. The 12 needs to be negative so that it multiplies to a negative number but still subtracts to a positive. So I know that I can now split my middle term. Okay, so I'm going to rewrite this as 9x squared, but then instead of writing this 12x that used to be there, I'm going to write minus 12x plus 24x minus 32. Okay, now I'm able to group because I have 4 terms. So I'm going to group those two and group those two. I'm going to take out a 3x, and I'm going to take out a 8. So now I know that my polynomial can be rewritten as 3x minus 4 times 3x plus 8. Now, that as a whole would just re-multiply back to our answer, right? So if I was to pick a blank over here to put that in, I'm going to put it back on the area line, right? Because essentially what I have there is a multiplication problem. It just hasn't been worked out yet. But if it were, it would still give me that same area. So really, those two things in the first blank and the second place are the exact same thing. This and this are the exact same thing. Okay, one is just written in a slightly different form. So the side links, if I actually had to turn these into side links, I would split them apart. Maybe this is 3x plus 8, and this side is 3x minus 4. Okay, 3x plus 8 and 3x minus 4. So what you're essentially creating are the two factors, the two pieces of the multiplication puzzle, the two side links when you're factoring. Okay, so now the perimeter. Same as I was saying before, you can't just add these two green things. We have to add all four. And if you need to label a rectangle to help yourself remember that, that's totally fine. I'm going to add all my x's first. So 3, 6, 9, 12. Okay. Negative 4 plus 8 is positive 4. Minus 4 is back to 0. Plus 8 is 8. Okay. So I have another one of these that I feel like you could try on your own. You're really just factoring and then filling in the blanks. Okay. So I pause it now. See if you can figure out this top one, number 3. I will say, if you follow this flow chart, the first step is still applicable here. You have to factor out any greatest common factor first. And there is one here. All 3 of those numbers up there are divisible by 3. Okay, so don't forget to do that step. Okay, but pause it now and see how you do with at least the factoring part. Okay, so when you factor it, you should get 3, because of that greatest common factor, times x minus 3 times negative 2x plus 7. Now, that is what's going to go on the same blank right here. 3, x minus 3, and negative 2x plus 7, okay? Now, technically, this problem should not actually be a rectangle because we have 3 dimensions here. We have 1, 2, 3 things. So technically, this shouldn't be a rectangle. This should be a prism because we have 3 dimensions, okay? So one of the dimensions is just 3. So maybe that's the height right here, okay? Another dimension would be x minus 3. Maybe that's the depth right there. And then the other dimension would be negative 2x plus 7. Maybe it's the length along the front. Okay? But we're multiplying 3 things together, so we need to label them as the 3 separate side lengths. Okay? So I'm going to go ahead and fill in the x minus 3 and the negative 2x plus 7. But just know that really I should have another blank for that 3. Okay? Now the perimeter, again, doesn't totally apply here because really this is a 3-dimensional figure. But if I wanted to start adding them, again, you would want to make sure that you have labeled everything, right? You'd want to make sure every single side was labeled with those dimensions before you started adding anything, okay? And we're not going to do it just because it doesn't totally make sense for this problem, but just keep that in mind, okay? So now here's number 4, which is the same type of problem. There's just no picture for you. Now, can you draw one? Absolutely. The area of a rectangle, so draw yourself a rectangle, is 6x squared minus 5x minus 4 square meters. If the length is 3x minus 4, find the width. So really, they've given us half of the problem already. They just want this side length right here. But I still have to go through the whole factoring process to get there, okay? So if you want to pause now and see if you can factor without me, go for it. I'm going to go ahead and just start talking through it, just in case you need one more problem worked out. So I've got 6x squared minus 5x minus 4. I need to start with the GCF. Well, 6, 5, and 4 have nothing in common. So then I'm going to move to grouping. Well, I can't group because there's not 4 terms. Is it a perfect square trinomial? Well, 4 is, right? But 6 is not. Bad. Difference of 2 squares, obviously not. And then that leaves me with the x factor. Okay? So the top is going to be a times c, negative 24. Bottom will be b, negative 5. So I'm thinking 8 times 3 will work here, and I want the 8 to be negative this time. So I'm going to use that to split my middle term, and then I will group, okay? I'm going to take out 2x. Now, if you notice, I've taken out 2x and I have 3x minus 4, but I also have 3x minus 4 right here. But I've already committed to grouping, so I have to take something out. So I'm going to have to take out a 1 here. Now, I go back to my problem. It says the length is 3x minus 4. Well, yeah, I see that right here. Check, 3x minus 4. So what's the width? Well, it has to be 2x plus 1, and that would be my answer. If you circled this down here, this whole thing, that would not be correct because you're circling the area. That's like me saying, hey, the area of this rectangle is 24, and this is 6. What's this? And you said, oh, 6 times 4. Well, no, what's this? What's this over here? And you would only say 4, right? So we just want to list one thing. Alrighty, the rest of these notes are very, very similar. So I'm going to have y'all try 5 on your own. I'll come back for the squares that you see on the back of this page, but the rest of them don't need as much explanation. So go ahead and pause the video and try this one. All right, so when you factor it, you get this beautiful answer. Then they're asking you what are the dimensions of the stage. So if I was to draw it out, I would split those two things apart. The length is maybe 2x plus 3, and the width is maybe x minus 7. Okay, there's no way to really know which one is official length or width unless they tell you something, give you more information. But for the most part, you just need to know that each one is its own dimension. Okay, the other thing I wanted to briefly talk about is squares. So the area of this shape right here, which maybe it's not a square, I don't know, is 49. But we all know that 49, literally its only factors are 7 times 7, right? So it has to be a square. And I can go ahead and label it that way. 7 and 7, area is 49. So if I was to rewrite the area, I'd have to write it as 7 times 7. Side length 1 is 7. Side length 2 is 7. But now what about the perimeter, right? If these are all 7s, to find the perimeter, I would need to do 7 times 4, or adding it 4 times, so 28. Okay? Same exact thing with this polynomial right here. Now you're probably thinking, how do I know if it's going to be a square or rectangle? You don't, and it really doesn't matter if you know it or not, because no matter what, you're still going to factor it the same. Okay? So looking at this trinomial right here, I need to go through my steps, right? And the first thing is greatest common factor. Well, 25's only factors are 5 and 5. That's not helpful. So let me go back to my flow chart. Here we go. Okay, so there's no greatest common factors. Check. Cannot be grouped because it's a trinomial. Is it a perfect square trinomial? Well, that's interesting. Okay, looking at that problem, this is a perfect square, right? Its square root is 5x. This is a perfect square and its square root is 8. Put those together and we get 40. Double it and we do get 80. So woohoo, we have a perfect square trinomial. Okay, so now looking at this, yes is my answer, and it says factor using the rule this. So either my answer is going to be a plus b squared or a minus b squared, right? So I see that because this is a plus sign right here, I know that my answer is going to be plus. So the way I get my answer is I take the square root of each piece. So square root of the first one would be 5x. Square root of the second one would be 8. Then because this is a plus sign, I put a plus, and I square it. Okay? So now, that is representative of the area, 5x plus 8 all squared. But now what does that mean about the side lengths? Well, just like on the square above, it was 7 times 7, which meant that the side lengths were 7 and 7. This is 5x plus 8 squared, which means the side lengths are 5x plus 8 and 5x plus 8, right? So I can almost label it that way, 5x plus 8, 5x plus 8, and honestly I could keep going all the way around. Okay? So, perimeter. Well, again, I would need to take this and add it to itself 4 times or just multiply it by 4, right? So I'm going to have 20x plus 32. Okay? There's one more of these, and I'll go ahead and tell you, oh, I didn't change the numbers. Whoops. Okay, hold on, pause. Okay, I think mine matches yours now on your paper. So 9x squared plus 54x plus 81. So again, we would go through the steps for factoring. Is there a greatest common factor? Yes, there is. Okay, I can actually take a 3 out of all of those pieces. So I'm left with x squared, no, whoa, not x squared, 3x squared, sorry about that. 3x squared plus 18x plus 27. doing something wrong? 9. Oh, I'm doing something wrong. Sometimes I like to restart these videos, but I'm going to leave that mistake in there. So the reason I knew something was wrong is I noticed that 3, 18, and 27 are all still divisible by 3. So sometimes y'all are going to make those mistakes too, just like I just did, and realize I didn't take out the greatest common factor. Okay? So, erase. Let me start over. Sorry if you're writing all that. 9. Here we go. There we go. Much better. Okay, so now I have a new improved problem, taking out the greatest common factor. So I go through the steps on my flowchart. Can I group it? No. Is it a perfect square trinomial? Maybe, right? Square root of this is x. Square root of this is 3. Put them together, we get 3x. Double it, what do you know? It is a perfect square trinomial, which means my answer is just going to be x, because that's the square root of this, plus, because that's a plus, 3 all squared. So that will be our area right here, which means our side lengths are x plus 3 and x plus 3. Now, the only thing I haven't talked about is this 9, which just like I mentioned on that last problem, that technically gives us a third dimension and makes this into a rectangular prism, really, because it's not a cube, because it's not like 9. We don't know if that's the same as x plus 3. But we know that one of the dimensions is 9, and then we know, oh, let me not label the bottom. Then we label these x plus 3, x plus 3, and then we'll make this the 9, because we don't know if x plus 3 is actually going to give us a 9 or not. Okay? So perimeter, again, kind of not going to work here because it's actually three-dimensional, but point is these all represent different pieces of the puzzle. X plus 3 is its own dimension, right? When you square it, it's no longer a dimension, you've made it into an area. Okay? So, oh man, look at this, guys. This is the same. Okay, let's change it. Cross that out. Let's make ourselves a perfect square trinomial. I'm going to do x squared, no, 4x squared. I'm going to do plus 9 at the back, and then a 12 in the middle. There we go. New problem for you. Hopefully that's not one I just did. Did I just do that one? No. Okay, good. So new problem. That's the area of the courtyard. So what is the length of one side, and what is the perimeter? Let's see. Start with the greatest common factor. Do we have a greatest common factor? No. Can I group it? No. Is perfect square trinomial? Yes, because I just made it that way. So I know if it is a square courtyard, that my dimensions should be the same in both places, right? So this square root is 2x. This square root is 3. This is a plus sign. Squared. So my two dimensions would be 2x plus 3 and 2x plus 3. You cannot write 2x plus 3 squared as a dimension. That would be incorrect. Okay? All right, one last problem. And again, y'all could probably do this one on your own. Is this the same one? Did I really just do that again? 9x squared minus 12x plus 4. Oh, no, it's slightly different. Okay, so y'all try this one on your own. It is a little bit different, but very, very similar. Y'all try this one, and then we really are done. Alrighty, so when you factor it, you get 3x minus 2 all squared. But what's important is that this thing is asking for the perimeter. It's not even asking for the dimensions or the area or anything. It's asking for the perimeter. So after you factor it, you realize the side lengths are 3x minus 2 and 3x minus 2. And then we add those together to get our perimeter of 12x minus 8. Alrighty, let me know if y'all have any questions. I think that was the end of it. Double check. Yes, it was. Let me know if y'all have any questions. Only one more topic to go. Woohoo!